here. Yeah, maybe tough luck this time, but I'll just keep it. And if they come to me, I'll just send it to them. And without further ado, let's just unveil the first one. The first place winner, we have Nguyen Tran, Fan Nguyen, and Jing from this University of Information Technology, Vietnam National University, and AI Vietnam Lab. Do we have the team here? Okay, that's fine, that's fine. But again, let's just congratulate all those winners for the challenge. Okay, so we have 5 great speakers with us on very interesting topics involving retrieval, involving ReID and stuff. So let's just welcome the first speaker, Qian Dong. Qian is a PhD student at Chee IR Lab, Tsinghua University. He's working on large language models, retrieval-augmented generation, text retrieval, and all those very interesting topics under the supervision of Professor Xiaoping Ma. So let's just welcome Qian for his talk. Okay, the floor is yours.
Okay. Hello everyone. Hold on a minute. Oh, okay. Okay. Good afternoon, everyone. I'm Qian Dong from Information Retrieval Lab at Tsinghua University. Today, I'm honored to present our work titled Decoupled RAG, an efficient and effectiveness retrieval-augmented generation framework via cross-attention. Okay. Retrieval-augmented generation, or RAG, has significantly advanced the capabilities of large language models. However, traditional RAG methods inject retrieved documents directly into the input context, which leads to inefficiency and challenges. In this work, we rethink how knowledge should be injected dynamically. One major challenge with in-context injection is efficiency. Injecting documents increase the context length dramatically, resulting in high inference cost and longer response times. Another issue is information loss and model degradation. The model becomes sensitive to the order of documents, leading to inconsistency. Moreover, injecting too much context interface with the model's internal reasoning capabilities, reducing its overall performance. To overcome these problems, we need a more efficient and effectiveness approach. An ideal RAG framework should decouple external knowledge from the input context and maintain high efficiency and robustness during knowledge injection. Our solution is decouple RAG by leveraging cross-attention mechanisms. We inject knowledge directly into the model during inference without modifying its input sequence. This enables seamless and efficient use of external knowledge. The first key component of our method is knowledge encoding. We pre-encode external knowledge into KV pairs. These representations are then ready to be injected efficiently during inference, avoiding the need for lengthy context. The second component is knowledge aggregation. We use cross-attention to inject relevant external knowledge representations at inference time. This way, the model can efficiently integrate external information without overloading the context. Compared to traditional in-context injection, decoupled RAG provides significant advantages, better efficiency, improved robustness, and a strong ability to maintain the model's internal reasoning without the performance degradation. We evaluated our method across various tasks, multiple question answering, slot fillings, and knowledge-grounded dialogue. Our baseline is vanilla RAG, fine-tuned with retrieval knowledge. We use the same retrieval modules to ensure a fair comparison. Our results show that decoupled RAG outperforms the fine-tuned vanilla RAG baseline, especially when injecting larger amounts of external knowledge. This demonstrates our method's effectiveness. In terms of efficiency, the inference cost of decoupled RAG grows linearly as the number of knowledge entries increase. In contrast, vanilla RAG suffers from an exponential growth in cost, clearly showing the advantage of our method. We also compared online and offline knowledge encoding strategies. Here is a quick explanation of the settings. First, online decoupled RAG encodes external knowledge on the fly during inference without any pre-caching. Second, offline decoupled RAG pre-encodes all external knowledge before inference, so it can retrieve and inject knowledge more efficiently during decoding. Finally, in vanilla RAG, all knowledge is directly injected into the input context and processed together, meaning the model needs to encode everything online in the self-attention process, which leads to major inefficiency as context grows. We analyze the efficiency of knowledge encoding during different RAG settings. First, pre-caching knowledge allows offline decoupled RAG to maintain very minimal growth in the time overhead, even as the number of knowledge entries increase. Second, online decoupled RAG also show significant efficiency improvement over vanilla RAG. Because it decouples knowledge entries during the encoding phase. Finally, for vanilla RAG, the inference time for encoding grows with the number of injected knowledge entries, leading to high inference time. Okay, that's all. Thank you. I'm happy to answer any questions if you may have. Okay.
Very interesting talk. So if you have any questions, audience.
Okay, if you have any questions, you can contact me via the email. Okay.
Maybe I can. So how do you like differentiate between this knowledge versus context scene, and how this formulation helps this idea of like this retrieval-augmented generation?
I think the idea is come from the experiments during I tried the open source LLM such as Llama and Qian. As the knowledge injected into the context, the model's response become low quality because the model's instruction following capability become lower when the context is become longer. For example, if I put the knowledge after my question, the Llama 3, sometimes maybe a response, a wrong response, such as it tend to summarize my input, not answer my question. So that's motivated me to think a new solution to better inject the knowledge without resulting a longer context. Okay, that's all. Thank you.
That's the speaker again. And next up we have. Just give me one moment. Next up, oops. My fault. Perhaps. Give me one moment. Next up we have Zhang from National University of Singapore. Zhang is a postdoc in the US, and he obtained his PhD from the University of Science and Technology of China in March 2024, and his Bachelor of Engineering degree from also USTC in 2019. His recent research focused on recommendation systems in LLMs and agent personalizations. So just give me one moment. I'll bring up your slide. There you go. Yes, thanks.
Hello, everyone. I'm Zhang from the National University of Singapore. Currently, I'm a postdoc focused on the learning model personalization topic. The title of my talk today is Leveraging Memory Retrieval to Enhance LLM Personalization. This talk includes 3 parts. The first part is about the background of the LLM personalization and the memory retrieval. In the second part, I will introduce my works on this direction, and in the last part, I will give a brief conclusion and future works. The first question is about what is the LLM personalization. Generally speaking, it refers to shifting the learning model from one-for-all paradigm to the one-for-one paradigm, making the model can satisfy the user preference and the needs. The objective of the LLM personalization including 3 aspects. The first one is understanding user data, and then reasoning the user preference, and finally accomplish the personalized tasks. After achieving the LLM personalization, we hope that different users can receive different response to the same questions based on the user's preference and the user needs. For example, when a child and when an adult ask the same question, the response from the LLM could be different for the 2 types of people. So the child, the response should be more cute. We strongly believe personalization is a key way for the learning models to be more widely used in the real world and benefit more people. And some recent update from the leading generative AI companies also prove this point. Just 2 weeks ago, the OpenAI highlighted their personalization features in their latest product. And also just 3 weeks ago, another leading generative AI companies, MedRAG, also announced their latest product, highlighting the personalization features. So we believe the personalization is one key direction for the future of the learning model research. Learning model personalization can be utilized to enhance various of downstream tasks, also including the information retrieval. Regarding the information retrieval, there are different product formats. However, we can unify them in a same function with potentially taking the query user and the context as the input and finally output the user needed content. When the input is only the query, this refers to the search task. When the user is also included in the input, this is a personalized search task. When the input is a user, this is a personalized recommendation tasks. And when the context is additionally included, this refers to the personalized contextual recommendation task. When both the user query and the context are inputted to the function, this refers to the personalized conversational recommendation or search tasks. For this task, LLM can provide a better intervention interface, and the personalization allows us to customize the model's output to better align with user preference. So LLM personalization is our permission to solve these information retrieval tasks. To achieve personalization, the core is modeling the user preference. However, user preferences are usually implicated instead of explicited. That means the user preferences are indicated in the user history data instead of directly represented by the natural language. And for the user preference, there are both the long-term and short-term preference. So that means we need to model all the historical data to capture the user preference. However, regarding the user data, it is streaming come in. So the history data could be very long and in the length over the user life. So this raises question about how can we effectively deal with such streaming coming data over the user life. We think a permission way is the memory plus retrieval framework. As this figure shows, we could first store the user data in the user memory. And when we need the history data to help the LLM generation, we could utilize the retrieval to find some most useful information from the user memory and input to the LLMs to help generate the personalized output. In this framework, when new user data is coming, we just need to update the memory instead of the model to capture the user interest. And if the memory is large enough, we could store the lifelong user data in the memory. As we all know, the memory cost is usually less expensive than the cost of computation for the large models. So we think the memory plus retrieval framework is an economical pathway towards the LLM personalization. To implement this framework, we think there are 3 research questions. The first one is regarding storing the information in the memory. That is how to construct the memory better. That means which type of information we need to store in the memory. The second research question is about the retrieval and refers to how to retrieve the most useful information from the user memory. The last research question is about the generation. After we have retrieved the useful information from the memory, how can we leverage the retrieval result better to generate the final result? Last years, I have focused on these 3 research questions and conduct some work. Next, I will introduce our works on this to answer these 3 research questions one by one. The first one is about the memory construction. So the study problem is how to build the memory better from an information storing perspective. many existing work directly storing the raw data to construct the memory. However, the user data could be redundant, and not all the information is important for personalization. For example, in the review generation tasks, some part of the review just includes the description of the movie content, so it is not related to the personalization, and the other comments are more related to the personalization. So in this case, we need to only need to store the core information that related to the personalization in the memory. This research question, which type of information is related to the personalization? To answer the question, we find some result from the social science, which can be summarized in one sentence here. It's our difference make us unique, and the unique shapes the preference. That means for the user preference, the difference information is the key to represent the preference. However, existing work usually capture the personal data pattern while ignoring the inter-user comparison to extract the difference. So that means they cannot utilize the difference to better represent the preference information to construct the memory. To solve the problem, we propose a difference of aware method for memory construction. That is, to construct the memory for each target user, we would compare the user with other users to extract some difference information and summarize this difference information to represent the user preference, and then storing this information in the memory to construct the final memory. To implement this difference aware method, key question is how to extract the difference. We think there are two sub-questions. The first one is that because we need to compare to other users to extract the difference. So the first sub-question is about which user to compare. And the second sub-question is about which difference to extract. Because the difference, there are many dimensions of the difference, and only a part of the dimensions of difference is related to the personalization. So we need to answer the questions, which difference to extract. To answer the questions, our answer is the selective user comparison and the structure difference extraction method. To answer the which user to compare, we just select some representative users for comparison. Specifically, we cluster the users into different groups and just take the central users of each group as the representative users for comparison. And to answer the question of which difference to extract, we predefine some dimensions to structure the difference extraction. It includes 3 dimensions, including writing style, emotional style, and semantic content. So in such a method, we can extract the key difference information for personalization modeling and construct effective memory. This slide shows the comparison our method between our method and the baselines. This the first table shows that the difference between our method and other personalization method we can see that our method is the only one method that can utilize the difference to construct the memory. And the below table shows the performance comparison. We can find with the difference for the memory construction, our method can achieve the best performance on the personalization tasks. After constructing the memory, the second question is how to leverage the memory better. That means how to retrieve the useful information from the memory. The challenge is in that for target predictions, not all the information in the memory is useful because the user preference could be diverse. And for target prediction, only a part of preference is related to the predictions. So the researcher question how to define the useful part of the memory for the target prediction. Existing method usually rely on the semantic similarity retrieval to find the useful information. However, as we showed in this slide, the preference can be reflected in the different dimensions beyond the semantic similarity. So we think this is not optimal solutions. And we think that manually design the retrieval strategies is hard. So we consider learn to retrieval. And the core is to score the retrieval result based on the LLM's regeneration qualities and use the scores to fine-tune the retriever to learn the retrieving process. This slide shows the detailed method implementations. And this framework is implemented under the memory transformer framework. The memory is built by the KV value of the self-attentions. And the retriever is MMP layers. And we directly combine the short-term or say the local context with the retrieval result in the large models to generate the final result. Our goal is to learn the retriever, train the retriever to make it can learn the retrieval the useful information. To train the retriever, we first would make each element in the memory could serve as a retrieval result and use large models to generate a prediction result and using the prediction quality as a label for each element in the memory. And we directly utilize these labels to train the retriever to learn the how to find the useful information in the memory. So this is the core idea of this method. And our experiment shows that this method can achieve 5% improvement in personalization performance. After retrieving the result, the next question is how to leverage the retrieval result better. As we all know, the large model is pre-trained for the natural language tasks and is pre-trained to deal with the textual data. So the retrieval result of the user data could have a different fidelity to the pre-training data. And the task of leveraging the retrieval result for large model output generation could also be different from the task of the pre-training of the large models. So to bridge these gaps, tuning with the retrieval result is widely used to solve the problem. And existing result shows that such a method can significantly enhance the performance. However, we find existing work blending infinite data by equally training all the input. We think such a method could may fail to fully leverage the user data for preference modeling. As this figure shows, the input to the large models could be split to two parts. The first part is the user data, and the second part is non-user data. For example, it can be the task instruction and related to the pre-training knowledge in the large models. The non-user information is more easily utilized by the large models because it's more stable and general and has been learned to leverage during the LLM pre-training process. And we think the user data is hard to be leveraged by the LLMs because it is dynamic and the diverse and could be different among users. So if we blindly fit in the data by equally training the non-user information and the user data, the model may be prefer to over rely on the non-user information to conduct the prediction. So the user data cannot be fully utilized to generate the final result. So to solve the problem, we propose a method called the counterfactual fine-tuning. The core idea is to emphasize the rule of the user data on the model predictions explicitly by leveraging its causal effect to fit the training data. Compared to this figure shows the method compared to previous supervised fine-tuning method directly contain the user data as input to fit in the training data. We add additionally part named the causal loss. This causal loss use the difference with the historical data, that is with the user data, and comparing the result with the user data and comparing the result without the user data, and use a difference to fit in the training data. This difference represents the causal effect of the user data on the model predictions. So if we directly add a loss that utilize this causal effect to fit in the data, then we can infer the rule of the user data on the model predictions. This causal effect computational process is obtained via the counterfactual inference, which can be formulated in this equation. And when really representation, it can be directly obtained by the difference between the with the history and without the historical output. So this method emphasize the rule of the user data on model predictions by leveraging its causal effect to fit the training data. This slide shows the result. We conduct experiment on the recommendation tasks. We apply our fine-tuning method to existing generative recommendation method. We can find after applying our CFT fine-tuning method, our method can achieve significant performance improvement. This shows that our method can enhance the utilization of the user data to enhance the preference modeling. So that's all that's the part of our works on these predictions, answering the questions about how to construct the memory and how to leverage the memory and how to leverage the retrieval result when the large models generate the final result. So in conclusion, in this work we discuss the memory retrieval framework, and we think that it is a permission pathway for the LLM personalization. And from the memory construction perspective, we propose a difference-aware construction method. And regarding the how to retrieval from the memory, we propose learn-to-retrieval method. And regarding the improving the leverage of retrieval result, we propose a counterfactual fine-tuning method to enhance the modeling of the user data in the learning models. So there are some future works. The first one is still about the memory construction towards the true lifelong modeling. I have discussed one most advantage of the memory is to model the lifelong user preference. However, in our work, we have not really implement this. So in the future, we need to really implement the lifelong modeling. For memory construction, I think there are three research directions. The first one is about the information extraction. Can we beyond the difference to can we beyond extracting the difference information to construct the memory? And the second one is about the memory updating. Because the user data is streaming coming and the user preference could change over time. So we may need to deal with the conflicts between the history and the current user preference and to extract the new user preference. So the second part is about the memory updating. And the third direction about the memory construction is about the memory architecture. Currently, there are both implicit and explicit memory. However, we don't know which type of architecture is better. And regarding the retrieval, currently our retrieval strategy are statics. And for different users, we think the retrieval strategy should be different, and the strategy should be updated with time going. The last part, I think, could be the how to leverage the retrieval result better is one permission direction is utilizing the reasoning ability of the learning models to enhance the leverage of the user data. Okay, that's all. Here are some related tutorials and the surveys and the workshops about this direction. If you are interested, please, you can scan this QR code to focus it. That's all. Thank you. Is there any question?
Your approach is fix the LLM serving at the reward network.
So do you refer to the second work? Okay. So what's the question?
Your fine-tuning
only.
Is fine-tuning 10 is 7 billion.
Sorry, I forget. This work is focused on the Qian. This work is focused on Qian 2. Yeah. No, 1.5 billion.
Second question is your method can be end-to-end?
Yeah, this method is end-to-end, but this work is not end-to-end. We need first to provide a label for the memory elements. So the label should be generated in a separate process.
The recommender responsible for computing the Keynotes
recommender train source. So do you mean the train cost for the loss? Train loss is keeps the same to the latest prediction loss of the learning models. So this work has some difference. In this work, we emphasize the normal loss refers to the latest token prediction loss, and this loss is somewhat different. We call it cost loss. It utilizes the cost effect of the user data on the model predictions to fit in the data label. So this loss is different from the latest token prediction loss. This is a code language. Do refers to the intervention in the causal intervention in the code language. Do long refers to we set the edge as a reference state. Then in our scenarios, the reference state refers to without the user data, without the historical sequence, also without the user data.
Mind if I throw in some one or two further questions?
Okay.
Okay, sure. So thank you for the talks. Very interesting to learn this suite of retrieval generation. So, would you mind first share with us the user difference construction part? Because I wasn't sure if I captured it correctly. So how do you construct the pairs to do this difference between users? As I thought, this difference seems to be like the core part.
Okay, so you mean how to extract the user difference, the difference between the users and which users to compare. So about which user to compare, we just select some representative users, and the representative users is selected by the group central users, the central group users. So after we have make sure which users to compare, we can directly utilize a learning model to extract the difference. And the difference extraction is for some predefined dimensions such as the semantic, writing style, and emotional tone. We predefine some dimensions for the learning models, and making the learning models following these dimensions to extract the difference by comparing the selected users and the target users.
Okay, sure, thanks.
Okay.
Thank you again for the talk. And next up, we have Xuejiao with us. Xuejiao is currently a Wallenberg NTU presidential postdoc fellow in at the Nanyang Technology. Echoing. Oh, my bad. At the Nanyang Technological University, Singapore, where she obtained her PhD, supported by the Not an 80s Wallenberg Foundation. Xuejiao collaborates with a group of researchers exploring AI in healthcare, large language models, knowledge graphs, and human-computer interactions. So, yep, let's welcome Xuejiao for her talk. Just give me one moment. I'm not sure about the, you might need a separate web page for the YouTube content playback. Okay, sure.
Okay, thanks for the introductions. Oh, how to start this? Okay.
There we go.
Okay, hello everyone. My name is Xuejiao from Nanyang Technological University and Lily Research Center. And today I will show this a MedRAG. Yeah, it's currently already get more than 10,000 views from the social website. And I and Liu Siyan, who is my research assistant, will introduce this paper to you. He's also the co-first author of this paper. And this work is cooperate with Tan Tosen Hospital of Singapore. Okay, please allow me to introduce my team. It's called SNOW Team, Science, Innovation, Wellbeing, and it's funded by the Charlotte and Alice Wallenberg Foundations and NTU, and it's founded in 2023. We focus on the task, use the scientific knowledge to improve the healthcare and the well-being, and include the mental, physical, and the social welfare. we have a lot of partners. For example, like the Tentusen Hospital. We also cooperate the Far East Hospital of Taiwan and some hospital of China. Also have some hospital of UK. We also have some cooperation with some universities like KTH, Qian Jiaotong University. So there's still some space. It's yeah, wait for you. We welcome the cooperations. So as we know, there are about 0.79 million people disabled or dead due to the misdiagnosis in US per year. And at the same time, we also have a lot of electronic healthcare records from different hospitals. So this should be the very valuable reference resource for the doctors for diagnosis. So if we can use it very well, we can use the senior doctors' experience to guide the junior doctors. It should be a very valuable resource. But as we know, the electronic healthcare record, or called EHR, is very confidential. It's not so easy to like use to train the large language models or put online. So RG provides very good solutions for that. RG retrieval-augmented generations. We can use some prompt to search a local document, and then we use the retrieval document to make it as a prompt to the large language model and use the information we want to query and the retrieval document together to generate a response. Yeah, so it's very suitable for such a solutions, but it's not suitable for the medical domain. Why? Yeah, here is an example. And the existing RG algorithm and the large language model, the accuracy is not so high. It also has the vagueness problem, because maybe they give us suggestions. It's a kind of back pain, but it's a lot of kinds of back pain. What kinds of back pain you have? So, and then the method of existing RG is also heuristic-based method. It do not have the reasoning capacities. So we try to use the knowledge graph to solve such a problem. What is knowledge graph? Knowledge graph is a kind of graph with the node is entity like Da Vinci, and the Mona Lisa is another entity. So Da Vinci paints the Mona Lisa. Paint is their relationship. Knowledge graph constructs the entity and the relationship in such an explainable format. So it has the capacity to explain what's the decision I make and why I make such a decisions. So if combine the reasoning capacities of knowledge graph to the RG, it should be solve the above problem. This is the methodology we propose. We propose a framework for healthcare Copilot, which called MedRAG, and it have 5 very important modules. First, the input of our system is EHR data, and also can text to describe your questions, any questions you want. And it also can use the voice. You can just speak to the MedRAG, and they will collect the voice informations and do the analysis. The output of our system is gives the diagnosis, suggestions, treatment, and medication. We also provide the follow-up questions. How we make such a solution come true? And the first is also the very important part is we construct a diagnostic knowledge graph, and we use the EHR database. We will extract all the diseases inside this database, and then we will do some disease clustering, and we will make this very similar disease together. And then we will use the hierarchical aggregation module to make different layers, and we will identify which part is upper side part, which part is lower side part. What's the relationship of the belong to, and then we will use the expert to check the correct or not for all the disease knowledge graph. And after that, we will do a large language model augmentation to the diseases knowledge graph because the existing, so for example, the manifestations or symptoms is not include all the patient because if the EHR database include 5,000 people, but it still have other kinds of diseases not included in this database. So we will do augmentations for all the diseases with their more detailed manifestations or symptoms, and then we will get a diagnostic knowledge graph. After that, we will use the input. For example, a doctor want to search a EHR patient to get the similar patient or solutions. We will use the EHR data input by the doctors. We will extract all the features. This is called features decompositions. And after that, we will get the embedding of different features. And after that, we will use the different features to match in the diagnostic knowledge graph. And after we match, we will do an upward traversy. This one will try to find very more high-level diseases. For example, this kind of patient is like two kinds of different diseases. We will upward traversy to find the root diseases, and then we will use this root diseases to find all the endpoint diseases, so symptom and manifestations, and combine this diagnostic difference knowledge graph together, and then we will input into the large language model. And this one is we will search the EHR database to find very similar cases, and then combine the very similar cases and the patients, the current patient's different manifestations, and then we'll combine the diagnostic knowledge graph and for these three informations together to do our reasoning, and then generate the output, the diagnosis, treatment, medication, and the follow-up question. Okay, this is the UI of the healthcare Copilot. We already said our MedRAG is not only for one diseases or one department of the hospital. If you use different departments EHR data, we will generate a different department's healthcare Copilot. So this one is generated by the 10,000 hospitals data and it's used for diagnostic the chronic pain, 慢性疼痛, it's called Chinese. So the UI is very similar, follows the ChatGPTs, and it's have the speaking mode and upload a file and the typewriting mode. The doctors can choose each of them, and we also will record the existing search histories from the left side. And here is the output of the doctor's input patient's data, and we give the diagnosis and instructive follow-up questions. For example, some junior doctors, they don't know what's more information I need to collect from the patient. So we will give some instructive follow-up questions, and we will also give the pain and treatment suggestions. For example, give the what kinds of exercise you need, what's the manual therapy, and some technique you use to relieve your pain, and also the pain medication treatment suggestions. Okay, so the next is how our model's performance. My research assistant Liu Siye, well, very excellent boy, will show you the performance of our model. Okay.
Thank you. We conducted our experiment to compare the MedRAG and with 6 other sort of MedRAG RAG models, and we can see that on the accuracy, and also we compare with the different granularity, and you can see that
the different granularity, the accuracies will both achieve the best and also even the second best performance. And on the most granular metrics on the L3 accuracy, we achieve over 11% improvement. And we also do the on the text report and also the the meditation suggestions and also the treatment suggestions. There also we do the traditional how we evaluate the text generation. We can also see that we use the four metrics: Breuss-Schneeweis, Breuss-Schneeweis, and Metilda, and we achieve the best performance on both of these metrics. And additionally, we carried out a subjective evaluation. That is, we used the Minisex criteria on these four aspects: the medical interviewing skills, the humanistic care, the comprehensive diagnostic abilities, and the treatment abilities. And we use the GPT-4o to score on these four criteria, and the result was validated by a doctor, and we achieved 290 out of 360. That is much better than the second best SRAG, that is the 277 out of 360. And we also conduct some experiments on different large language model backbones, including the open source models and the closed source models. And horizontally, we can see that without the Qi-elicited reasoning component and with our MedRAG, the Qi-elicited reasoning, we can see there's a very huge improvement, like especially on the most granular, on the L3 accuracy, like from for example, like the Llama 3.1 instruct on the 70 billion, we can see that the accuracy is from 56 to 71, and also like in the GPT-4o, we have improvement from the 60% to over 73%. It is quite a huge improvement. And we also evaluate our proactive diagnostic question. And this is a very interesting mechanism we propose in this work, that the purpose of this mechanism is to how MedRAG can guide junior doctor to ask the key questions about the key differences. And we can see the performance that from the different masking ratio is from like 52% to 66%. And this is part of the result of our clustering. And we can see that this is how we cluster the different diseases into subcategories and then a category. And this is the part of the demonstration. And this is a diagnostic knowledge graph then of the CCPD dataset. And this is how the hierarchical structure of this dataset and also calculated by our MedRAG. And very interesting is that this is an example I want to point out that, for example, we have two diseases. The first one is lumbar canal stenosis, and second one is sciatica. And they, on most situations, they have a very similar symptoms. For example, they have a symptom of tingling, numbness, muscle weakness, but there's only one symptom that is different, actually it's opposite, that if one patient has the lumbar canal stenosis, he will, the pain will relieve when he's sitting, but it get worse while walking. But the sciatica, the person with sciatica, they will, when he's sitting, the symptom will be worse, much more worse, and it will be relieved while walking. This is opposite. So this key diagnostic difference will be augmented to the knowledge graph we construct, and this will be injected to the prompt of this large language model. And this is the few application scenarios, and actually our MedRAG was deployed and to some clinical scenario. And the first one is the decision support and the treatment and the medication suggestions. And like as I mentioned before, we use the question guidance and health management and the medical copilot. And here is our short demo of our MedRAG.
In modern society, diagnostic errors are common, costly, and often disastrous for patient health outcomes. Statistics show that about 0.79 million Americans are permanently disabled or die each year due to misdiagnosis. Some world-class healthcare institutions have accumulated a huge amount of EHR data. These EHRs condense the valuable diagnostic and treatment expertise of experienced doctors and are a rich source of high-quality medical information. If we make good use of this data to guide patients, junior doctors, and other medical practitioners, it has the potential to reduce diagnostic errors, enhance care quality, and provide better medical services.
To achieve this goal, we launched a healthcare Copilot called MedRAG with 10,000 hospitals of Singapore. MedRAG works as a medical AI assistant to provide diagnostic disease support, such as potential diagnosis, treatment, and follow-up questions. This can mitigate biases and increase efficiency for healthcare practitioners. There are 3 ways users can easily interact with MedRAG. You may chat with it directly, or upload an EHR file, or just type in your question. By leveraging the advanced large language models and the RAG algorithm enhanced by large graph-elicited reasoning, we effectively utilize high-quality EHR data for diagnostic decision support. This approach significantly improves the accuracy of the existing heuristic-based method and addresses diagnostic barriers, particularly for diseases with similar manifestations.
MedRAG has achieved a maximum accuracy of 91.87% in testing across various datasets and has set new state-of-the-art benchmarks in diseases diagnosis. MedRAG can be seamlessly integrated with various open source and closed source large language models, such as Popular GPT-4, Llama 3.1, and Qian 2.5. By building on MedRAG, these models can achieve up to a 41% improvement in performance. 3 powerful components of MedRAG guarantee excellent performance. For each EHR database, a diagnostic knowledge graph is constructed systematically through a series of advanced techniques. Then, the diagnostic differences knowledge graph searching components, the patient's clinical features are mapped to the diagnostic knowledge graph to pinpoint key diagnosed differences. After that, the component will integrate knowledge graph-elicited reasoning capabilities, the knowledge extraction ability from private datasets from RAG, and the powerful linguistic capabilities of large language models to provide diagnostic recommendations with high accuracy and specificity, including proactive inquiry suggestions. Now, let's see a short demo.
Hi, I'm Chris, your healthcare co-pilot. Let me show you how I can support clinical diagnosis with my 3 awesome modes. Let's start with the EHR mode. You can simply upload the patient's EHR, and I'll analyze the data right away to provide you with accurate diagnostic recommendations in just a few moments. For the consultation mode, we will unobtrusively collect consultation content in the background, providing real-time diagnostic insights, suggesting follow-up questions, and offering treatment recommendations when a reliable diagnosis can be determined. For the typewriting mode, you can ask me any medical question, and I'll provide accurate answers or guidance combining with the private EHR datasets you provide. It's perfect for quick on-demand medical queries. Discover the power of MedRAG, your ultimate healthcare co-pilot.
And thank you.
Questions from the audience.
The first question is about the documents. Documents are typically lengthy and large model generally struggle with the long test. Is this document a long test case? Is it a medical research paper or a medical survey?
Pardon?
Uh,
You mean the document is what kind of document?
yes, yes.
Okay. Okay, actually, our document is a kind of electronic healthcare record. It's from the hospital. For example, we will have the patient's name, the age, what's the pain locations, and what's the pain descriptions, and what's the pain type, and what's the kind of medicine he already take. Yeah, such a like of format.
You use this data used to construct a knowledge graph.
Actually, we use the diseases, only use the diseases. For example, a kind of low back pain. Yeah, we use only the diagnosis to make the knowledge graph, not all the informations.
And the second question is, it seems that this method doesn't involve fine-tuning.
Yeah, actually not include the fine-tuning because this is the basic situation of the RG. They all not use the fine-tuning, only retrieve the document, and so it's high rely on the large language model, which large language model you use, the performance. But our team also have another project called the Special Lab. Yeah, it's fine-tuning the whole model from very basic and then generate a very professional doctors. Yeah, we also have another project. You can focus from my home page. Yeah.
The third question is, I want to know how large is your knowledge graph?
How large?
Yes.
How many node and how many relation? Siyan, do you know the detail?
Because the construction of this knowledge graph is based on the EHR file, we call it a file pool. Because, for example, the public in this paper, in X class, there are over over 120,000 patients. So there will be more than there will be over 120,000 nodes of disease, and there will be more nodes on the symptoms or other manifestations on that. But we just use a very small EHR file, for example, the CCPD, and that is a very private data set from our corporate hospital. And the EHR files they provide to us is actually quite limited. So in that case, the scale of that problem is small.
Yeah.
Oh, okay.
Yes, I think it's also a kind of limitation for the whole RG technique. The RG technique uses a prompt to input all the information like reasoning you want, but it's also have the limitation for the token size of the prompt. Yeah.
Final question, I want to know, will this mode eventually function as a general list?
Pardon?
General list. It will perform like a general list.
General what?
General list.
General doctor? Oh, yeah, actually, we design this, if the database, we use the general doctor's database, it also can use by the general doctor. It can customize by any EHR database you use, and it can give suggestions to different kinds of doctor, yeah.
In this case, it uses...
Colleague pay,
Okay.
yeah.
Thank you.
Thank you, thank you.
Yeah, I do have one more, if that's possible. So yeah, just again, thank you for the talk. And just was wondering, because I saw this multi-layer, the hierarchical tree construction for the RNG, for the knowledge graph. So I was just wondering, will there be conflicts when retrieving from those multi-layers of a hierarchy of symptoms, right? And if there will be, then how do you like handle this one? Do you just use LLMs and their reasoning capability for this?
What kind of conflict?
Maybe I'm not sure because I feel like maybe let's say if I catch cold, right? So maybe they have like a node level of symptoms that's just called a cold, or maybe some higher level stuff, but that's not necessarily maybe the super version of like this all those cold related diseases. So would there be like any conflicts between this higher level and the lower level?
Actually, our technique is designed to solve the conflict like you described. Some diseases, they have a very, I can speak here, no problem. Some diseases, they have a very similar manifestations. Yeah, so if this disease is too similar, but it still have some key different, our system is try to find such a kinds of key different. For example, a patient come and we find the existing symptoms and we get is very similar to two kinds of different diseases. So we will try to find what's the key difference of these two similar diseases. And then we will give into the large language model, and we have two different choices next. First is ask the doctors to query the patient. What's the key difference you have the different, and then also give the doctors two kinds of different suggestions. So you can maybe the doctors you have these two kinds of different choice, and the key difference is like this, and then you can make the decision for as your knowledge. Yeah.
So there's like a built-in pipeline.
Yeah. You ask the key point of our technique. We use to solve such a kinds of conflict. Yeah.
Okay, so that sounds very good. Thank you so much.
Thank you.
Okay, so let's thank the speaker. And for our fourth speaker, we have Metilda with us. Metilda is a second-year master student at Tsinghua University, supervised by Professor Zhang. Her research interest includes personalized retrieval, recommendation systems, LLMs for recommendations, and stuff. And prior to her graduate study, she earned her bachelor's degree from the National University of Singapore. So we have, yep. Just give me one moment. Let me bring up this one, right?
Oh, great.
Okay, just give me one moment. Let's make this go away. Okay, thanks. Floor is yours.
So much. Okay. Okay, hi everyone. Sorry, I'm having a cold, so I sound a little bit different. My name is Metilda, and I'd like to share with you guys a piece of work that we did. It's called PerSRV, Personalized Sticker Retrieval with Vision Language Model. Yeah. Oops, sorry. Okay, so this is the outline for today, and let's get started. So a quick introduction. I think all of us must be really glad because we don't have to use post nowadays for essential communications. We also don't have to use a pigeon to communicate because nowadays we have the instant message. So we can really nicely and effectively communicate with each other in real time. And the really fun thing about instant messaging is that we can actually use stickers. So as you can tell, we have WhatsApp, Telegram, WeChat. They're all instant messaging platforms. And with the aid of stickers, we can express ourselves much more better. But the fact is actually sticker retrieval is actually really challenging because why? Well, firstly, we're not searching from a traditional search query. We're actually trying to express a particular sentiment. So that part is a little bit hard to capture. The second part is every one of us have a different style when we come to sticker selection. So how do we actually accurately capture that? And in addition to that, we know that stickers, they are static, dynamic, they are multimodal images. So that how do we actually retrieve in that case? So how do people actually do it now? So the first thing is a lot of the current solutions require sticker labels or context. So for instance, the one on the left, we actually need to manually label the stickers with emotions and reply response. And this is very laborious because we have a lot of human input in it. And then for the right-hand side, we actually need to capture the user's utterances, which might not actually be available at the point of time. Secondly, a lot of these work actually lack personalization. So is there something we can do to improve this entire user experience? So this is our main contribution. We introduced PerSRV. The first thing is we address the personalized sticker retrieval task. This is, as far as we know, the first LLM-based personalized sticker retrieval method. And extensive experiments on a large-scale real-world data set from WeChat demonstrates our solution's efficacy. So this is our method. This is the end-to-end, and I'll talk about each component one by one. So starting off, we put our framework into two parts. We have the offline and the online processing. And in the offline processing, we have three main parts. The first part is sticker semantic understanding. And this part's main goal is to capture all the semantic understanding of a particular sticker. So given a sticker, we pass it through three components. The first is a supervised fine-tuned vision language model. You can understand it as a query generator. So it generates the query given a sticker. And the second, the blue one, is a vision language model. So we're just using a basic vision language model. And here we elicit descriptions and emotions from the sticker. And the third is optical character recognition, where we try and extract text from the sticker. And lastly, we integrate the historical click queries from the sticker. So this means past queries affiliated with the sticker. So with these, we have a bunch of like text information about the sticker, and we call this the semantic representation. And the second component is sticker utility evaluation, where it comprises of three main parts. The first is sticker popularity. That's really straightforward. It's how popular a sticker is. And we also have cross-user adaptability, where we try and find out how many unique users enjoy a particular sticker. And lastly, we have query adaptability, which is how many diverse queries a particular sticker has. So say like, for example, this sticker on the top, it has like, say, 4 queries. We would expect maybe the more the better because it's able to fit to more scenarios. And the last component we have is user preference modeling for sticker style. So this part, we try and capture a user's style. So here, given a user's historical sticker list, we pass it through a pre-trained image encoder, and we get these image embeddings, and then we cluster them to form the personalized style. So that's for offline calculation. We have gathered all the information through offline preparation, and then we go through the online processing. So what happens is, firstly, the user's input comes in, and we use a utility boosted semantic relevance recall. And then we use the style to rank. And finally, we have a sticker output list. So that's our main method. Next, let's talk about some experiment. And before I talk about experiment, I'll just quickly share with you guys our data set. This is a closed data set, which comprises, I'm just gonna highlight a few because there's a lot of tables going on here. The highlight is 540,000 stickers with about 145,000, which is the row right at the very bottom, about 30% not comprising of any accurate text. So we really need that vision language model to help to fill in those gaps. So let's talk about some of our experimental settings. This is our evaluation metrics. We follow the multi-MRR and recall. We have 4 main categories of baselines: popularity, text, general VLM-based, and sticker ranking method. So for our experiment results, quick glance, I'll just walk through each of them quickly. Popularity doesn't really fare that great, maybe because one size doesn't fit all. And text-based performs rather fairly, especially when we incorporate OCR text inside. General VLM is not performing that great either, probably because users aren't searching for sticker description, and we actually aren't able to capture the unique scenario of users' intention query versus what a sticker actually means. And lastly, the sticker ranking method really struggles with a high candidate count, so therefore we're not seeing great results as well. So this is our ablation study. Our results improve with inclusion of each component, and personalization is really important. I'll just walk through some case studies here. So this is a particular sticker, and let's see how we can actually understand the sticker semantics. So firstly, the OCR text here says in Chinese, 以后不许这样了. And in OCR, in English, it says, next time don't do this. The ground truth is not allowed next time. So it's not exactly similar to the OCR text in this case. So when we elicit from the base model, the description and in motion, this is what it is. And when we ask a base model to generate the query, it's actually incapable of doing so. It just repeats the prompt in itself. But while we're using a fine-tuned model, we realize it's, even though it might get distracted from the OCR text, it's still capable of accurately generating the user search query. And this is applicable to most of the other data set that we have. For instance, from the blue score, using a base model and generating the query almost gives us no relevant good results. But when we fine-tune the model, we realize that, hey, actually it's performing not that bad. And similarly for cosine similarity as well, because cosine similarity calculates the similarity between the embeddings, so it's a lot more relaxed, and blue is a lot more strict, and hence there's a huge contrast between the two results. Then we talk about the component number 2 that we mentioned in our method, which is the utility module. And given a particular search query and the ground truth, initially without utility score, our ground truth is actually ranked on the 4th. And with utility score, we actually notice that our ground truth is ranked all the way in the front, including personalization modules as well. Given a user's historical style preference clusters. For instance, this user really likes cats, really like this Korean idol, and really likes Lina Bell and this ghost. And given a particular user search query, without personalization, we don't even see the ground truth at all. But with personalization, we notice that, hey, actually we can recall this much more accurately and much more precisely as well. In terms of efficiency, PerSRV has a much lower inference time than other methods, while still having the best retrieval results amongst all baselines. So in conclusion, stickers are an integral part of our online conversation, and we are the first LLM-based sticker personalized sticker retrieval method, PerSRV. Personalization is really important, and our experiments show that we significantly outperform current methods. I have a little slide after this. I would like to talk about a little gap in our previous work, which we address in our next piece of work. I don't know if you guys realize, but we actually only used one data set because it was provided in the challenge and in the paper, and therefore we had a struggle during that, and therefore we decided to curate our own large-scale user sticker data set. So this piece of work is published in StickIR 2025. It's called USticker, a large-scale multi-domain user sticker dataset for retrieval and personalization. It's the largest publicly available dataset comprising of 22,000 users, 8.3 million utterances, and 370,000 stickers. Multi-domain, multi-language, we have English, Chinese, Spanish, Russian, everything. Temporal, which means it contains time information, but we have really rich user information. And qualitative, quantitative experiments demonstrates applicability in user behavior modeling, sticker recommendation, and retrieval. So how does the data set actually look like? It looks something on the right, where we have users, and then we have stickers, and then we have some conversation data. So how does it actually compare, and how does it fare with other data sets available? We are the only one with the most ticks. We have history, we have sticker, one of the largest, we have the largest stickers in the publicly open domain. We have the most number of languages as well. So what are some of the applications? So if you're looking at doing recommendation or personalized retrieval for the sticker scenario, personalized sticker generation, you're looking at user behavior understanding or conversation understanding, you can consider this data set. So yeah, thank you very much for listening, and that's the talk for today. Thank you.
And we have questions from the audience. think I have a few questions.
Yes,
So
please.
first of all, I think this is a very challenging task, right? It's a sticker recommendation. So how do you actually factor in some of the more sophisticated emotions like satire or sarcasm? Like what if I just say something but I meant something else? Is able to capture this kind of like
You capture a really real way, because when we talk in conversations, we have sarcasm, we have irony, right?
yeah.
And also we have a lot of cultural things. So for example, in the Western world, we use memes, but in China, maybe we use a lot of gong. And it's complicated. So right now, I don't think we are still relying very much on user historical queries and a lot of fine-tuned query generators. So in this sense, I think we're still learning from past sticker representations for the queries in that sense. So as long as our data set is large enough, technically it should be able to capture all these ironies or sarcasm inside. So, but the fact is, like, how do you make sure like the data set is large enough, right? And so my point was, like, the next piece of work, maybe we can incorporate more of that and have a more robust sticker retrieval method in that sense.
Yeah, that definitely motivates people towards like collecting maybe some of the temporal informations and all of the context of it. Yeah, that sounds very good. And the other thing is like, I remember like during the last few pages of slides, you mentioned something like 8 million utterance from 20K.
Yeah.
20K.
22,000.
20K users. That's a lot of spamming though.
So these are firstly,
my maths are not that good, but I feel like that's hundreds of utterance per user, right?
yes. These users, they are very, very active. So they speak a lot. We crawl the data over about a span of 2 years or so. Yeah, so it's not like I'm just like 2 days. So.
Yeah, that's because it happens in 10 days. That feel like spamming to me.
You know? Yeah. So you're completely right. Firstly, spam advertisements do exist, and we try our best to capture them. And you might ask, hey, how do we actually capture them? And we use the very traditional method of just like trying to look for them.
Yeah, sure.
Yeah, just to make sure. And so, so to the question about whether or not so it's over 2 years, so I think it's still fine.
Yeah, that should be all right.
Yeah. Thanks very much for the question.
Yes, thank you so much.
Thank you.
Do you have any other questions? Yeah. You have.
Yeah, please. Right, I love this question because I think I've been asked this question every single time I talk about this. Someone will ask me about dynamic users. So obviously, currently, our method is unable to do it in real time other than re-understanding what the user's preferences are. So I think our future work definitely needs to integrate to incorporate the dynamic change of users' preferences over time. But the first thing is you need a data set that actually contains this temporal information, right? Which is what the last part of it was, where actually, when I was talking to Yunpeng today, was like the fact that we need to have the time data first, and then we can talk about how we can use this time data to then integrate users' dynamic change in their preferences. So that's the key first part, and then we can talk about how we can adapt according to their dynamic personalities over time. Yeah. Thanks very much for the question.
Okay. You do very interesting job. So thank you for your presentation. And I have 2 questions.
Yes.
First, I want to know, does this model support metaphorical reasoning?
Sorry?
Metaphorical.
Is this the similar question?
Speaking Chinese, 它可以支持隐喻吗？就是隐喻就是
Can you give me an example?
For example,
yes.
Use animals to represent some political ideas.
I think it's a very similar question as well. Like, how do we capture all these indirect attachments to the sticker, right? Like a sticker, there's too many condensed understanding in it. So my answer is like still the same. As long as the data set is large enough, we should be able to capture it. But we need to have a large enough data set first.
Okay.
Thanks.
The second question is, can GIFs or videos also be processed? GIF.
Oh, yes. So in our data set, we have GIFs. And sorry, what's the second extension?
GIF and videos.
Videos.
Yes.
Actually, I think we incorporate the same technique. We just slice them up and then understand them frame by frame. So I that's no problem. Yeah.
Okay. Thank you.
Thank you very much for the question.
Questions?
All right.
Okay, so let's thank the speaker again. Finally, we have our fifth and final speaker, Philipp. Philipp is a co-founder of Beamster, the software company, and he's a software developer focusing on augmented reality, computer vision, artificial intelligence. And he obtained a master's from the Bowling Green University in Ohio, USA, and he's also and an MBA from Johannes Kepler universities in Linz, Austria. He's also pursuing a second master's in computer science in the same university, and he has been like interested in personal reality and similar stuff since 2022, where he started the development of Beamster, which is a very cool app. I got to have a sneak peek prior to this. So just give me a moment, I'll set up this remote session for Philipp to join. Yep, I think he's it. Just search for Philipp. I saw him just. Yep. So I just stopped screen sharing on my end then. Oh, I see. Yeah, I've talked to him on email a moment ago, and he said he's online. So just maybe give it a moment or two. Oh, he declined it. Oh, geez. Yep. Just let me email him. But yeah, Philipp, if you're online, maybe just accept the. You got it? Oh, yeah, that's great. Okay. Hey, Philipp.
Hello, can you hear me?
Yeah, we can, but you might need to share screen, but how do I do it?
I can share the screen, 1 second.
Hopefully I'm doing it right.
I can do it, 1 second. Roll. Yeah. So good afternoon, everybody.
Hello, we still haven't seen your screen.
Yeah, it's sharing already. It's yeah. The ball is spinning.
No.
Second. Oh, okay. Well, 1 second. I have to do something.
Yeah, this remote sessions is always.
Yeah. Can you see something else?
Yeah, I think we got you.
Wonderful. So shall I get started with my presentation?
Yeah, sure. Go ahead.
Yes. So thank you for inviting me. As you introduced me already, Philipp Breuss-Schneeweis. I'm from Austria, and together with my colleague Roman Vogelhuber, who is here as well, I believe. I sent him the link. We developed a game called Beamster, and we had the initial idea I had the initial idea when I was watching my kids playing tag me if you can. You know, they were running after each other, but not like the regular catch me where you really try to tag the other person. But they were trying to take a picture of the other person. So I thought this was kind of an interesting idea. You know, you try to catch somebody by taking a picture of the person. And here, when you can you hear me well, just in general? Is audio good? Because now I can't hear you anymore. Yeah, so I go on. And so here you see on this phone on the left, you see that the person is holding a smartphone. Here is a person in the background, and there's also a little dot in between, and this is kind of a target. And when the person presses the screen, the app basically takes a picture and then looks for a person in the picture, and then uses person re-identification to see who this person actually is. We also visualize this by some kind of laser. You kind of see it here. And then we also, when we identify the person, we can really display here a message that in this case is German. I hit Lisa, and I also can kind of put some paint on the screen. Yeah, so this was actually the initial idea, and then I was searching for how actually to do this technically, and this is when I found the GitHub repository from Zhang. And I tried it out with a few reference images, and it right away worked. I also asked him a few questions. He was very helpful. And then we had the technology together, me and Roman, to actually develop this app, which meant that we had to put the whole code on mobile and so on. So I will talk about this in a second. Just next slide. Yeah, so just once again, this is me, and this is Roman, and you've heard the introduction already, our intro during our bio in the introduction. And here you see the scanning process. So before this actually works, before you can do person identification, you of course have to tell the image who the players are. And therefore we implemented a scanning option. So ahead of each game, so actually it works like this, that when you start a game, when you initiate a game, other people can join the game. And here you see actually this waiting room on the screen. And then here you see the waiting room, and here you can click then please scan, and then the scan screen opens. You continuously press the button, and we are taking a couple of reference images. So this is the scanning process, and then this all happens on the phone. We calculate feature vectors, and we only upload the feature vectors to a server. And when the game starts, each of the players downloads. So when you press the start button, then automatically each of the players uploads all the feature vectors from all the players, and then all the person recognition happens then on the device. So which is then really fast. So during the game, you take a picture, you immediately recognize the person, and you can then go on with the game. What happens next, I will show you then in the slides. Yeah, here you see again the scanning process without an animation. So basically what this is then, so Beamster is a laser tagging app. So that's how we call it. And it's really something new. So we initially, when we launched it, we thought it was really cool, but we had a hard time kind of explaining what it really is, because such a game doesn't really exist. So we then settled on laser beam because this is the best way that people understand what it really does. And now I can show you a quick movie. I hope you can hear the sound.
After years of home office, companies are getting creative to lure employees back to the office. Some even develop fun apps, making the company of your colleagues more fun. But little did they know, they might have unleashed something far greater than they imagined. An app to play tag. It starts small. A glance, a spark, and suddenly the office transforms. Team building redefined. Competitive spirit reignited. And your workplace now a scene of James Bond. Your colleagues aren't just teammates, they're your playmates. And Beamster? It's not just a game, it's the reason you'll want to come back to the office.
Well, yeah. So yeah, what makes this game unique? I talked about this real quickly before. It uses person re-identification. It's also an active game, so people really are moving. Then it's person versus person in real life. And what we also think is really interesting, so it's really that you as a person, you are part of the game, not an avatar. And so what you saw now is really the MVP of this game. So it's simply you join, you can then play against each other, and there is one man. So the winner is actually the last person still in the game after like 5 minutes, whatever you want the length of your game to be. So it's basically a tag game, but you can now already do a team fight by assigning players to teams, and when you add the player name at the beginning of the app, you just say team 1, team 2, in addition to the name of the person, and then you can play it like this: that the last person who remains of a certain team, this team then wins. So we have it's as I said before, it's a tagging game. We really try to avoid having really shooting sounds and so on. That's why we make sounds like bloop, so more like game sounds. But you could, of course, make a really real life ego shooter out of this. And also where we think is a lot of potential is some AR glasses integration. I have already from Snap the new spectacles glasses, and then you could even see much more what's happening, because right now the whole game happens basically within the app, and you see the lasers within the app. But if you had glasses, you could really visualize also the lasers that are shot at you. So I believe this. I have another screenshot then in a second. Just a question also about privacy. So as I said before, we don't upload any pictures to the server. These are only the feature vectors. Only this the hash, yeah, which is the one that's loaded to the server, and which is then distributed to the other players so that the person re-identification works. And now, as we know, that the original image cannot be reproduced from the hash. And this way we are doing it makes person identification on the app really fast. And the technology, real quick, as I said before, the scanning happens on the mobile device, and also the whole person, as I said, here the person re-identification happens also on the mobile device. Then the feature vectors of the scans are stored on the server. And each client, so we have Android and iOS so far, has during the games has all the feature vectors on the device. So when you take a picture, all the AI happens on the mobile phone, and the retrieval of the feature vector and the search of the feature vectors, of course, is then really fast. And the messaging, I haven't mentioned this yet. So when you actually tag a person, yeah, we are sending XMPP messages. So this is a messaging protocol to the server, of course, but also to the other player. So we can tell the other player that he has received a hit. And then the phone vibrates a little bit when you are hit, and the screen color changes, and for a few seconds you cannot shoot again after you have been hit. So this also happens with XMPP, and there are many messages, of course, floating around when there are a couple of people playing. And yeah, the market, we'll click the next steps in our marketing initiative. So far, we have done very little marketing, only testing. We have the app is available in English, German, Dutch, and Chinese so far. We can easily add additional languages. And we had also one presentation so far at some local gaming meetup here in Austria. It was really fun. So during the game, at the end of the presentation, we actually made a little Beamster fight. Yeah. And me and my colleague, we had, of course, the app. We wanted to start it. And then there was the QR code on the screen to join the game. And then actually a couple of people from the audience joined the game as well. And we all had a little Beamster fight on stage. So we saw that this works out really well. It's really fun. You can even try it out now at the conference as well. And another thing, the university where I'm studying AI at the moment, it's a master program part-time that I'm doing more or less for fun because it really interests me, of course, and also for this app here. We're having next weekend a gaming weekend, and where we play lots of games, Mario Bros and Minecraft and whatever it is, also board games. But we also have a little Beamster laser tag tournament. So this will be fun. I'm going to make some videos, and in case you want to know how this turns out, let me know. And these are the Snap spectacles. I mentioned this before. These AR glasses, and you can really do things like this. So you could have the phone as your controller. Yeah. So rather than shooting a laser beam through the camera, you could really hold it like this. Likely, I'm not sure. You still need the. Yeah. Now this is something we still have to discuss. But you can really visualize much more within the glasses. Yeah. So I'm not sure now if you're using if we would use the camera which is on the glasses actually to capture the shot, or the camera of the phone. This is something that we still need to decide. And yeah, lastly, if you have some questions, you can contact me per email, bill@beamster.com. And of course, you can also try out iOS and Android. And I really think that Beamster could be really interesting for the Asian market. And also when we look at our server, I didn't mention this yet. So we see, of course, people playing it because the app is online worldwide. But it's not like that the server is exploding. Yeah, so everybody in the gaming industry knows it's very hard to do some marketing. And so far we haven't found or actually talked to any influencer also. But if you have an idea, if you know somebody, some gaming company in China who would be interested to help us publish this game in China or promote it, let us know. Because we also know, as I said before, the app is available for iOS and Android, and I believe Google Play is not available in China. But you need a Chinese company registered in China actually to publish a game on Android in China. That's how I understood it. But if you know anybody, or if you have an idea who could be interested in this, I would be really glad. You can send me an email. Thank you very much. So this was my presentation. If you have a question, let me know.
Okay, thanks, Philip. Thanks for the presentation. I think it was very cool though to be able to finger gun someone and like just play in the office and stuff. But you might want to caution the people to exercise extra caution when playing near the stairs and stuff, right?
Yes, I'm here.
Yeah.
Of course, it's really you mean like if you have to take care, so not to drop the
because you don't want
phone
to
and
fall
things like
down the
this?
stairs, right?
Yeah, so we don't have so much experience how this really works out, how when people play it's cool and so on. If it's dangerous, it's something new, definitely. And we might have to add a warning that don't drop your phone or something like this. We have already a warning in there that we're using augmented reality, and actually some other apps, they have some warnings that you really take care and you don't run on the street and so on. So I think that there could be a danger, of course, if people, get really excited and run around. But this is with any other game as well, of course, so that you, when you play in real life, you have to watch what else is happening.
Yeah, sure, definitely. Do we have any further questions from the audience? Okay. So thank you, Philipp. Thank you for joining us online.
All right. Thank you. Thank you for letting me presenting me Beamster.
Okay. See you a lot. See you around.
See you. Thank you.
Okay, so just give me one moment. That's everything from us today. We are very happy to have you all joining us on this ACM Web Conference workshop on multimedia object reality, and we are looking forward to maybe seeing you again in future occurrences. Okay, so enjoy your stay in Sydney, and we hope you a very good time here. It's a very welcoming country, and it has some of the nicest sands and beaches in the southern atmosphere. So just enjoy, and also the food is great. Okay, thank you so much.